Okay, back to soaps. First of all, I noticed that these slides are kind of skew from my video here. I'm not going to go redo the video. What I'll do is I'll check PowerPoint for updated PowerPoints, and this will be lipids, and you can use that as the main reference for it. So listen to this while you go through the PowerPoints. If you have questions, just let me know, and I will answer them. Okay, so soaps. Soap's a pretty big deal these days with the coronavirus, and we're going to see why it works better than anything out there. Okay, why does it work better than hand sanitizers and everything? Also, the structure of soap is going to explain, first of all, how it works, and also what we're going to learn is the structure of soap is very similar to what we're going to see in cell structure. We're going to also see how it relates to protein structure and DNA structure. So what you learned from soap here is that the structure of soap is basically very similar to when we talk about the structure of cell structure, proteins, and DNA. Okay, what makes soap kind of special? And soap is really easy to make. You can just take some lard, and what you do is you add lye to it and mix them together, and you make soap. And that's how soap has been made for centuries. It's really easy, and it's a great thing to have, right? So what the thing about it is when you add the lye to the fatty acid, what the lye does, it turns the fatty acid from being all nonpolar to having it partially polar. So what it does is it turns one end of the molecule, we call that the head, makes that polar, while it makes the rest of the molecule, the tail, you'll see in a second, nonpolar. The polar part will interact with water. All polar things interact with water through this dipole-dipole interactions. And the nonpolar parts will not interact with water and will interact with each other really well through London dispersion forces. Okay, so this shows a picture of a soap molecule. What happens is after you add the lye, the H pops off and you're left with a negatively charged oxygen. That makes it a polar. So this guy is called the polar head. And this part here is nonpolar. And we say it does not like water. We learned that that's not true. But it essentially moves away from water for all the reasons talked about before. And so you can separate. So the nonpolar part will move away from the water, and the polar part will move towards water. Okay, so when you put soap molecules in the water, what happens is the water pushes the hydrophobic tails together, just like it pushed oil together when you put oil in water. And when it does that, the tails will increase their interactions between each other. So the first thing that happens is the nonpolar parts get pushed together because water wants to get to itself. And when that happens, the tails interact with each other much better, and they actually stick together a lot better than they would individually through better London dispersion forces, LDFs. Also, the hydrophilic heads, the polar heads, stick out and attach to the water through dipole-dipole interactions. All right, and this forms what is called a micelle, and I'll show a picture of that in a minute. Okay, so what holds soap together are two types of interactions: London dispersion forces of the tails, and dipole-dipole of the heads of the water. And this makes this structure of micelle very stable. All right, so this is a picture of a micelle. The green parts are the hydrophilic heads, the polar heads, and they're sticking out towards the water, interacting with the water. And then you have the hydrophobic nonpolar part that are stuck, all pushed in the middle, forming a strong London dispersion interaction between the nonpolar. Okay. All right. Okay. What I will do is I'm going to go do a little video in a second to show what happens when you use soap. But essentially, this is what's going to happen: is that the micelle structure is going to trap the grease or oils and hide it from the water, in a sense making the nonpolar parts, or the grease and oil, which are hydrophobic, invisible to water. And then the water doesn't know where the oil is. It's trapped inside the oil droplet. Okay. All right, I'm drawing a hand here from the side, like that. Okay. There's your thumb and your other fingers, and here's the palm of your hand, right here. Fingers. See how good that looks? There we go. Okay. All right. Your hands, especially the palms of your hands and other parts of your body, but let's just talk about your hands. On your palms of your hands, there are sebaceous glands, and those sebaceous glands secrete oils. Okay. All right, and they're there for many different reasons, to keep your hands warm and other things. But one of the things is that the oils on your hands is really the key to keeping your hands clean, keep them clean. What happens is that the oils of your hands will trap dirt and germs, like the coronavirus. Okay. Now, what happens is that you got the coronavirus on your hand, and it's stuck in that oil of your hand. And what you do is that when you go and touch something, you wipe the oil off from your hand, and then on that, it will carry the virus or dirt with it. Okay. So what you like to do is you would like to get the virus off of your hand, the germs, the dirt. And the way to do that is to get the oil off of your hand. If you get the oil off your hand, you will get the germs off your hands. So a way to do that, and one way to do that is real simple. It's not to use soap, it's actually use gasoline. Okay, nonpolar substances dissolve nonpolar substances. If you take gasoline and pour it on oil, it will dissolve the oil. Okay. So if you want to wash your hands, one way to do it is to take gasoline and pour it on your hand. And when you do that, what it's going to do is going to dissolve the oil on your hand, and it's going to pull away the dirt and the germs. Okay. We do not want to use gasoline to wash our hands for all kinds of different reasons. We could, it works really well, but we want to try to do it a different way, and that way is to use soap. Okay. So this is going to relate to how you wash your hands and the method you wash your hands and why it works. Okay. So when you take soap, draw a soap molecule here. So here's a soap molecule. It has a polar head and a non-polar tail. Okay. So when you wash your hands, you just don't take soap and add it to your hands. It won't work that way. And that's because the soap molecules do not know how to orient themselves when you do that. You have to have them orient themselves just right. If you put the soap on your hand without water, is that these guys would just randomly set themselves up on your hand and your oil, and it would do no good. So what you have to do is you have to force the soap molecules to orient themselves in the right way. So the first thing you need to do is to add water. What you do first is you wet down your hands. Okay. And when you wet down your hands, you add the soap then. And when you add the soap, when you put the soap in the water, what will happen is it will try to form a micelle. Okay, but what it's going to do is the tails are going to naturally be attracted to the grease, the oils of your hands. Okay, that's because they're forming London dispersion forces. Okay. Meanwhile, the heads will be sticking on the outside interacting with the water. So you get two types of interactions here with the soap. Okay, the soap is going to interact with the water through dipole-dipole. and it's also going to interact with the oils of your hands through London dispersion forces. Okay, so what you do is you add water, and then you add soap. And then what you do is you mix the soap on all over your hands to make sure it's getting all the nooks and crannies to get into all that grease in there. And then when it happens, it orientates the tails, the nonpolar tails, to the oils of your hands, and the polar parts stick on the outside. After you get done doing that, what you have is you have your oil of your hand is trapped inside the micelle. And therefore, in a sense, all the water is looking at this giant piece micelle, and all it sees is polar heads, and it likes polar parts. So it starts to interact with the micelle. Okay, so now what you have is that basically that micelle now can be lifted off of your hand by adding more water. By adding more water, okay, what that's going to do is going to separate it from your hand and separate it from the hand. Now this thing here, this whole thing here, just looks like a giant polar molecule in water. And then when you add more water, rinse your hand, it will pull this guy off of your hand and take away the grease that's trapped inside the micelle. And you got a clean, you remove the grease, the oil from your hand, your natural oils, and in that natural oils were the germs. And you got a clean hand. Okay, so that's how soap works here. This is really important. That's why they say wash your hands for 20 seconds. What you're doing, you've got to do it right though. You got to add the water first so they can set up the environment so that soap molecules can orient themselves in the right direction. So the polar parts are sticking out into the water, and the nonpolars are attaching to the grease. The oils of your hands. Okay, and then when you scrub your hands, that's trying to get all the oil exposed to the soap. And then when you rinse the hand, what that does is it pulls the micelles off your hand, become soluble in water, and it takes them away. And you're clean. And you don't have the germs anymore. Now, there's another effect that the soap does as well. One of the things that the soap does is, other thing it does to the coronavirus in particular, it actually turns the coronavirus inside out. So it can't do its job anymore because it's destroyed. And that's because what it does is it turns essentially it rips apart the cell wall of the virus by these same interactions, and the virus becomes useless by that. All right, so this is a cartoon of what happens after the micelle forms around the oils of your hands, okay? So after you've added the soap to your hands, this blue part out here is water. So these are the heads of the soap molecules. They're attached to the water. And then inside here are your natural oils from your hands, which have the coronavirus and etc. Attached to it. All right, so that's how it works. It's pretty simple, and it does the job. So wash your hands. Okay. So hand sanitizers don't work as well. What they do is they try to the oil, the alcohol that's in the hand sanitizers can interact with the oils of your hand, and they can partially dissolve the oils off your hand. But one thing that they might not do is they'll take the oils off your hand but may leave the virus, so or germs. So it's better to use soap when you wash your hands. Okay. All right, I'll move on. I'll do another video in a second on phospholipids. Let's end with this one with soap.